This instructional video is designed to show you how to determine the number of significant figures you have in a given measurement. And so there are three rules. The first one is very straightforward. It's the non-zero rule. Anything that is not a zero is a significant figure. Second rule, I'll write in blue, and this is the sandwich rule. So anything that is a zero that is sandwiched between two significant figures is itself significant as well. And the third rule, I'll write that in green, is the trailing rule. And the trailing rule says that if there is a decimal, then trailing zeros are significant. So next, I'll write up some examples and count up the significant figures in them. So the first one is completely straightforward. 3, 4, 5. And so in this case, each one of these numbers is not a zero. So by rule 1, we have 5 significant figures. The next one, let's get a little more involved. We'll write 0.013500. So by the first rule, the 1, 3, and 5 are significant. There's nothing sandwiched between them, so the second rule does not apply. However, we have a decimal and we have trailing zeros, so both of these count. And we have 1, 2, 3, 4, 5 significant figures. Next, let's write 5, 3, 0, 2, 1, 0. In this case, the 5, the 3, the 2, and the 1 are all significant by rule 1. They're not zeros. We have a single zero that is sandwiched between Sig Figs, so by rule 2, that counts. And while we have a trailing zero, we do not have a decimal. So this last one does not count as a Sig Fig. So we have 1, 2, 3, 4, 5 Sig Figs. Next, let's try something that takes us even further out. 0, 0, 0, 2, 0, 0, 4. And so in this case, the 2 and the 4 are Sig Figs based on rule number 1. I can pick up the blue marker for our sandwich rule. We have 1, 2 here, and there are no trailing zeros after this decimal. These leading ones do not count. Since there are no trailing ones, we have no additional Sig Figs based on rule 3. So we have 4 here. Now, this can seem a bit involved and a little tricky, but if we use scientific notation, it's possible to make this much simpler, particularly for the trailing. So in this case, I'll write the first digit and then the others after its decimal. And now I just need to determine how many powers of 10. 1, 2, 3, 4. So it's very straightforward now to see that we have 5 Sig Figs in this first number. Here, I have the 1.35 and those zeros, and I will move it 1, 2 back, so that is 10 to the minus 2. And now I can see, based on the trailing rule, that these zeros are significant, and so that's the entire thing. In this case, I can write 5.3021. And this is 1, 2, 3, 4, 5 powers of 10. And so this trailing zero without a decimal does not count, so it is not written in the scientific notation. And finally, in this case, I move 1, 2, 3, 4. And this use of scientific notation in writing out our numbers reduces the ambiguity in determining how many Sig Figs you actually have.